So today's lesson, we start with a brief review of what we've already learned about rational functions. All right, starting with just a basic function here. Y equals, we can see we have a polynomial divided by a polynomial, and each of the polynomials, numerator and denominator, are in factored form. So all we're doing here is we're trying to figure out what the x and y intercepts are and what are the asymptotes, horizontal and vertical asymptotes. So let's start with the intercepts. Where do we find our x-intercepts? Just like when we found our x-intercepts when we were dealing with polynomial functions, whatever makes the numerator equal to 0, 0 divided by any non-zero number is just going to be 0. So that's one of the key things. 0 divided by any constant where the constant is not equal to 0 is equal to 0. 0 divided by 1, 0 divided by 10, 0 divided by -2, or whatever is 0. When y equals 0, that's when we have x-intercepts. So we can see this first factor, x minus 1, is the first factor. So x equals 1 would cause that factor to be 0. And x equals 3 would cause that second factor to equal 0. And if we write the x-intercepts as ordered pairs, we have 1, 0, and 3, 0. So those are the x-intercepts. And where we find those is when we look at the numerator. So when the numerator is equal to 0. So that's how we find those. Well, how do we find the y-intercepts? Well, the y-intercept, we always let x equal 0. So let's do this in our heads. If we let x equal 0 in this first factor, we get 0 minus 1. So we get -1 in the numerator times 0 minus 3, which is -3, over 0 minus 4, which is -4, times 0 minus 5, so -5. So when x equals 0, we get 3 over 20. 3 over 20, and so therefore we write that as an ordered pair, 0, 3 over 20. So that's our y-intercept. So that's where the graph is going to make contact with the y-axis. So now, let's do horizontal asymptote. So the horizontal asymptote can always be found by using the bubble theorem. Remember, big bubble over little bubble, that's no horizontal asymptote. Little bubble over big bubble equals 0. So the horizontal asymptote is y equals 0. And if the same size bubble, that's equal to the coefficients. All right, so what do we mean by bubbles? Well, the bubble, the size of the bubble, is determined by the degree of the polynomial. So if the degree in the polynomial is bigger, so that's the degree of the polynomial is greater in the numerator than in the denominator, there's no horizontal asymptote. The graph of the function, the fraction, keeps getting bigger and bigger, either negative or positive direction. So that's when we talk about it in behavior model. But in this case, you should see that the degree in the numerator is a 2, and the degree in the denominator also is a 2. So the degrees are the same. The degree is a 2. So if the degrees are the same, we peel off the leading coefficient. Well, what are the leading coefficients? So it's 1 times 1, which is 1, and any number out here gets multiplied by these numbers. So that number is a 1. So bottom line is, whatever number's on the outside, as long as each of these coefficients is also a 1, the numbers on the outside, the ratio of those numbers, y equals that ratio, is the horizontal asymptote. Always write your horizontal asymptote as an equation, if there is one, as an equation that starts with y equals. So y equals 1 is our horizontal asymptote. Forgot to put a box around the x-intercepts. And then the vertical asymptote, well, we talked about that by kind of like when we want to find the x-intercepts, we're looking for the x values that make the numerator equal to 0. Well, for our vertical asymptote, we're looking for the x values that make the denominator equal to 0. Only, the denominator only. Denominator, okay, equals 0. Well, where does the denominator equal 0? Well, it equals 0 when x minus 4 equals 0, or when x equals 4. It equals 0 when x minus 5 equals 0 also, so when x is equal to 5. So those are the two vertical asymptotes. And again, just like horizontal asymptotes, we want to make sure we write those as an equation, because asymptotes are lines, and lines have equations. All right, don't just put Like the common mistake is to do this. Vertical asymptote equals 4. That's like a bad accident. You don't want to do that. Okay, make sure you write it correctly. X equals 4 or x equals 5. We're going to get to later, well, what happens when an x value makes both the numerator and the denominator equal to 0? Well, let's go ahead and talk about that now. So this is kind of like later on we're going to do this, but if a real number makes both the numerator and the denominator equal to 0, okay, equal to 0. It's not an x-intercept, not a vertical asymptote. It's where there's a hole in the graph. It's where there is a hole in the graph. Where there is a hole in the graph. And like I said, we're going to get to that later. All right, so that's it for now. Again, just to recap. X-intercepts, whatever x values make the numerator 0. Y-intercept, just let x equal 0 and simplify the fraction. Horizontal asymptote, use the bubble theorem. Same size bubble, peel off the coefficients. Y equals that number. Bigger bubble on the bottom, that's when y equals degree in the denominator is bigger, then y equals 0 is a horizontal asymptote. Numerator degree is higher than the denominator, no horizontal asymptote. Vertical asymptote, are the x values that make the denominator equal to 0 only. Again, if they make both the numerator and the denominator equal to 0, it's where there's a hole in the graph, and like I said, we'll get to that later.